right, welcome back. So we're going to move on here to Objective B, or Part B of Chapter 2, however you want to phrase this. And in Part B, we can see we're still finding the slope. So all the methods that we just used in Part A are going to apply. I would tell you we're mostly going to be dealing with y equals mx plus b. But we're going to go back to our geometry days and talk about parallel versus perpendicular. So that's going to be an issue for us that we'll need to address, and let's address that right now. We have our notes already on the different aspects of slope, and what we're going to do, I'm going to make a new page here, and let's discuss what are parallel and perpendicular. Well, I think you guys can probably come up with this. So I'm not going to take a whole lot of your time with it. Parallel lines and perpendicular lines are special. That parallel lines never touch. If you remember your geometry days, parallel were coplanar lines, meaning they were laying flat and never touched. Whereas perpendicular lines intersected at a 90-degree angle right here. I'm not a huge fan of that line I just drew, so let's go ahead and try to at least make it somewhat looking like 90. Well, it turns out that their slopes of these lines have something in common. And again, you may remember this from your days of geometry, that in these lines, when they're parallel, you have the same slope. Whereas when they're perpendicular, there's something known as opposite reciprocals. Oops. And opposite reciprocals seem, I don't think we need a definition. But opposite reciprocals are talking that if one of the slopes is 2 to 3 over 2, then the opposite reciprocal of that is negative 2 over 3. You flip the fraction and make it a positive versus a negative slope. So both of those things will be in play here. And what we're going to do is, you can see from our last one, I'm going to skip back to it here, right here on this section. The directions weren't labeled here, but we're going to go ahead, and I'm only going to do a couple of examples here because I don't think it's really necessary that we do too much with it. We just need to remember parallel versus perpendicular. So what I'm going to ask you to do, in 37, I'm going to say, find the slope of a line that is parallel to this line. And then in 38, I'm going to say, find the slope of a line that is perpendicular to that line. The first step in all of these will be to solve this for y. So in this case, I'm going to subtract 4x, and I'm going to subtract 25. 4x, 25. Cancel, cancel, and I'm left with negative 5y is negative 4x minus 25. Divide by negative 5. And I'm left with y equals, and I'm going to clean up these fractions and simplify as I go. Just know that you can put them in your calculator, hit math, enter, enter. But what I end up with is 4/5 x plus 5. So that's where the thought process comes in. The slope of this line right here is 4 over 5. I didn't ask for the slope of this line. I asked for the slope of a line that is parallel to it. So we're going to remember that, well, a parallel line would be the same exact slope. So the line of any line that's parallel to it is 4 over 5. Watch what happens when we do perpendicular. The process for solving is unchanged. We're going to make our line. Now, in this case, I've got some stuff going on. In fact, I jumped to a conclusion there with my line. Let's go ahead And before we do that, let's rewrite that. Like so. And take a moment so you can see what I did. I basically flipped the equation around. Just like you could say that 5 equals x is the same thing as x equals 5. I could do the same thing here. I also moved some terms so it fit slope-intercept. Now, the reason I did that is because when I draw my line, the only step to solve this is to divide by -6. But let's be careful on this move from here to here. I'm a little concerned that might be too fast. So take a moment and make sure you can do that. If you need to, go ahead and rewind it so you can see what I did. Now, to actually solve this is that. So I know that the slope of this line is -1/2. The question is, what is the slope of a line that happens to be perpendicular to it? You need to remember that perpendicular meant opposite reciprocal. So I'm going to flip this and make it positive. So instead of -1/2, I get positive 2/1. And then I don't need 2/1, that's just the slope of 2. So on the last 2 questions here again, or last 4, sorry. I don't think we need too much practice on this because it is the same thing. You just need to remember, oh, I flip it or I don't for parallel versus perpendicular. So in these 2 equations right here, because they're not labeled, I'd like you to find a parallel line. And in these 2 equations, go ahead and do perpendicular. And that way, again, it's a practice solving for y, and more importantly, it's a practice on making the slopes fit. All right, take some time, finish those, and when you're ready, we're going to go ahead and we're going to be moving on to the last objective of this chapter.